So as it says on the screen, functional programming is right. And Erlang is a functional programming language, therefore it's right. So you're in the right place and we're done. That's all we need to fix. This is to say that functional programming is math. And with math, then we can be concerned about correctness, which means that we can prove a program's integrity. Contrast this with object-oriented programming. Objects encapsulate behavior within the context of state. If you change an object's state, you change its behavior without changing its interface. You can't reason about what an object is doing unless you can nail down its state. Here's a neat trick. Let's say you have 24 bytes of state. That's 6 32-bit words. With those 6 words, you can represent more different states than there are atoms in the earth. 6 words, 32-bit words. In pure functional programming, we have immutable data. It's easy to pin down data that doesn't change. It's also easy to share it with other people, other processes, when you know that they can't change it either. We have referential transparency. For any given input, our functions will always give us the same output. This is super easy for testing. It's also really easy to reason about. And it doesn't matter where we run one of these functions. Whatever machine we put it on, we'll always get the same result. Boom, you have a cluster. Finally, in pure functions don't have side effects. You put a value in, you get a value out. Nothing else changes. Not that we never need side effects. While mathematics might help us understand the world, they're not very useful. Math isn't very useful for changing the world. It's side effects that change the world. And I don't know about you, but I got into development to change the world. So let's look at how Erlang does functional programming. Erlang does variable assignment a little bit differently than we learned in imperative languages. In a simple assignment, I tell Erlang that the variable a is equal to 1. That's not like an instruction, though. I'm not telling Erlang to set a equal to 1. I'm merely informing Erlang that a is equal to 1. You can see the difference. When I try to tell Erlang that a is no longer equal to 1, now it's equal to 2. Erlang politely informed me that I'm wrong, not that virtual machine, that Erlang already knows what a is, and it's not 2. But note the way that Erlang talks about it. No match on the right-hand side for value 2. It's not an assignment, it's a match. Erlang is looking at the two sides of my equal sign and trying to see how they match. In this case, they don't. A is equal to 1. We've got a 2 on the other side, so Erlang gives an exception. The only reason Erlang let me get away with telling it that a's value was 1 the first time around was because Erlang didn't know what a's value was. A was unbound. But then I gave Erlang a logic statement. And from that, Erlang could infer that the unbound variable a had a given value. Erlang will do matching even when it needs to unpack the values to get to do the matching. It is important to note a couple of things. The unbound variable needs to be on the left side of the equal sign. Second, any bound variables that you have in your unpacking, they still have to match. So like in this example, if it had been 2, 2 on the right-hand side, it would have failed because a is 1, not 2. Erlang does a special unpacking job when it comes to lists. If you've ever studied Lisp or Scheme or some of the languages that are derived from Lisp, you might be familiar with cars and cutters. Anybody done that? Okay, one person knows what, 2 know what cars and cutters are? Okay, so that goes way back to like the 50s. And it's a register in an IBM machine. It's named after the register. We don't use it anymore except in Lisp and Scheme, other languages like that. In Erlang, we refer to heads and tails. Head refers to the first element in a list. Tail refers to all of the rest. Erlang does the same kind of pattern matching and variable binding when we define functions. If we define a function with an argument that's a constant, Erlang will only recognize this function when there's a match on that constant. Anything else will crash and burn. This example returns a value. You see how that works now? 0 is okay, you pass it in a 1, and it says, hey, I don't have a function clause that matches that. It's like saying, I didn't even define that function. Because I didn't, as far as Erlang is concerned, define that function. I only defined it when you pass in a 0. This example returns a value OK. That's not a built-in value for Erlang. It's an atom. Erlang's atoms are a literal data type where the name and the value are the same. It's similar in Ruby to like a symbol. OK has a value OK. This pattern matching business becomes more useful when we add in Erlang's multiple dispatch, or conditional dispatching. We can define the same function name with the same number of arguments in several different ways, and Erlang will use just the one that matches. In this example, we're defining 3 different versions of the same function. One for when the input value is 0, one for when the input value is 1, and one for the input value of greater than 1. That one is particularly interesting because in that version, in that third version, we're binding the value passed into it to a variable n. All Erlang variables are capitalized with the first letter. But then we've done something called a guard. We're saying this one only matches when the value that's passed in is greater than 1. Just like our 0 is OK function, if we provide an input value that doesn't match any of our declared functions, we're going to get an error saying that we don't have a matching function. Erlang provides a really rich environment for testing, but the easiest way to write a unit test in Erlang is to simply set up a match that you know to be true, or that you expect to be true. And all of the test libraries will trap that and say the test failed if it didn't come out true. Really, really simple. Erlang is concurrent and uses message passing to communicate between processes. That's what we're doing here. We've got a process that we know is Marco with a capital M. That's just a PID stored in a variable. And we're going to send Marco our own PID, process identifier, and an atom called Marco. Marco!
Hello.
Thank you. Then we wait for Marco to reply with Polo and the direction we should look. Erlang is going to ignore any message that doesn't match this. If we get a tuple DAC with 2 elements that starts with Polo, then it's going to take the second element, put it in a variable called direction, bind it to a variable called direction, and return that variable. Anything else is going to get ignored. Erlang's got really strong support for binary operations, and they're also based on pattern matching. So in this case, we're binding a base 16 number to to a variable called color. And you might recognize that color as orange. I don't know. Erlang programmers and colors, like 2 different worlds, right? When we ask Erlang to unpack color on 24-bit space, we can break it into 3 different bytes. And now we have the red, green, and blue components of that color, each of them bound to their own variable. This kind of pattern matching is really useful when we're serializing and deserializing data, regardless of where it's coming from. But we do this a lot, especially like over network traffic. So that was a quick overview of Erlang's version of functional programming. In just a handful of examples, we looked at immutability, referential transparency, pattern matching, message passing, and bit strings. No. Pattern matching, recursion, function definitions, multiple dispatch, message passing, and bit strings. That's more than half of Erlang's syntax in 12 minutes. Notice how every single code example relied on pattern matching in some way. That's how important pattern matching is to Erlang. I have a confession to make. None of the code in this presentation actually runs. The code is all good. It's just that I've mixed expressions and statements. And Erlang's REPL, the Erl shell, lets you type expressions but not statements. Erlang's programs are pretty much all statements defining functions. So in order to run the code samples, you'd actually have to type the functions into a module, then compile and load that module, and then write expressions from those functions. It's awkward. Erlang does provide another way to do it. I find that when you're working in the shop, you can define functions, but it's kind of like the way that JavaScript does it. Var something equals function, and doing Erlang and having it look like JavaScript is even more awkward to me, so I didn't show you that way. So we're going to move on to concurrency and some definitions. Distributed computing is when our concurrent processes work together on the same problem. Concurrency is when more than one process is running, but they don't have to be working on the same thing. We do this like at an operating system level all the time. Symmetrical multiprocessing is when we've got more than one core, and we spread our processes or our threads across more than one core. A process is a sequence of programmed instructions, either single or multi-threaded, that a computer executes. And a thread is a single sequence of programmed instructions that a computer executes. In a lot of languages, we consider threads to be lightweight processing. We consider threads to be lightweight and processes to be kind of heavy. Threads can get started up quickly, but processes are slow. Threads tend to share memory, and processes tend to be isolated. Threads use a little memory, and processes use a lot. Erlang is multi-threaded, but Erlang threads act more like processes, so that's what we call them. Erlang processes share nothing, they're isolated. We can only communicate between processes by passing messages. We can't share anything. They're isolated from each other. So if one process dies, it can't take down any other processes. Many people feel like many people say that Erlang feels more like an operating system because of this. Because processes in Erlang are as isolated as processes running in the shell. But really with Erlang, it's more like you've got multiple shells on multiple machines. Because Erlang processes don't actually care about what machine they're running on. Machine boundaries don't change the way that processes communicate. Ends up being trivial to scale from one machine to many because of that. On the one hand, Erlang processes still act a lot like threads. On the other hand, Erlang processes still act a lot like threads. They're tiny, like 618 bytes at the smallest. Tiny processes, really fast to spin up. It's not at all unusual to run tens of thousands of processes on one machine, and it's possible to run millions of processes on one machine. Joe Armstrong is one of the creators of Erlang, and he said that Erlang is more object-oriented than most modern object-oriented programming languages are. Another one of Erlang's creators is Robert Verding, and I asked him about this. He just rolled his eyes. He knows Joe. But Joe may be right. Alan Kay came up with the term object-oriented programming. And he said that he's sorry that he coined the term objects, because really the big thing is messaging, not objects. Either way, Erlang's primary abstraction is not the object, it's concurrency. Joe Armstrong calls it concurrency-oriented programming and says that Erlang is a concurrency-oriented programming language. When we're programming in a concurrency-oriented programming language like Erlang, we get some nice benefits. It's easy to distribute our system across multiple machines. We just start processes up somewhere else. It's easy to scale a system simply by adding more machines and redistributing the processes. It's easy to make our systems fault-tolerant by breaking them up across multiple machines and making some of our processes into supervisors that watch the other processes, and if they die, clean up after them. Erlang also comes with the Open Telecom Platform, or OTP. The name of this library is possibly one of the least fortunate parts of Erlang's history. At least outside of Ericsson, where Erlang was developed. It reinforces that Erlang comes from the telecom industry and suggests that it's a tool primarily for telecom. When newcomers hear that most Erlang programmers use OTP, it suggests that most Erlang programmers are doing telecom work, or at least work that's very, very similar to it, like WhatsApp. Erlang is not limited to telecom work. OTP is not limited to telecom work. I'm just saying they abstracted the telecom out of the library. They might have abstracted it out of the name, too. They didn't. And as long as I'm complaining about OTP, I'll add one more. A pattern language, Christopher Alexander's book on architecture came out in 1976. The Gang of Four book on software patterns came out in 1995. OTP was open sourced with Erlang in 1998, and they failed to predict that what they called behaviors, the rest of the world was going to call patterns. Aside from that, OTP is great. They're solid libraries with nearly 2 decades of proven use in large-scale, highly concurrent applications. In a talk called Systems That Run Forever, Self-Heal, and Scale, Joe Armstrong lays out 6 rules for creating a fault-tolerant system. Spoiler alert, Erlang is designed around these 6 things. Erlang does hot code swapping, and the Erlang ecosystem has strong support for fault-tolerant data storage. But both of these topics are a little bit out of scope on the talk. I don't think that they're really an idiomatic part of Erlang. But I'm good at scoping, so I'm going to say a couple of things. On the surface, Erlang's hot code swapping is really cool. But it feels like something they forgot to upgrade over time. It feels like we're still kind of stuck in the 80s. Erlang lets you load code in 2 different versions. The running version and the new version. You switch from the running version to the new version by just calling the function. So you run the code and it replaces the running version. It's an implicit reload. If you want to run explicit code swapping, Erlang has some functionality that will help with that. It's kind of like the rake tool in Ruby on Rails, or in Ruby. But sometimes also called the 9th circle of Erl. You get different levels of support and encouragement around that process. So Erlang's not perfect. In fact, a lot of people complain about the tool chain in general. As it happens, there's a lot of really powerful tools for Erlang. It's just that the community is sometimes small, and it's hard to find them and learn about them. Fault-tolerant data storage is solid, though. Besides Erlang-specific ets and dets and amnesia, I mean, like, who calls their database amnesia? There's no A in the middle of it, but amnesia, it's great. My two favorite NoSQL databases are also written in Erlang. It's Riak, and we got a guy from Basho who just walked in, and CouchDB. Plus there's RabbitMQ, which is different than a database. It's a message queue, but still, fault-tolerant stable method for storing and distributing messages has got a lot in common, and it's a really important part of a distributed computing system. Isolation and concurrency are the foundation for Erlang's processes that we already talked about. When I started thinking about which features of Erlang are idiomatic, which features are so integral that removing them would denature the language, concurrency was first on my list. I told you Joe Armstrong talks about concurrency-oriented programming languages. Robert Verding teaches about the fundamental difference between concurrency through shared memory and through shared nothing. Erlang, of course, shares nothing, and this is like the foundation for isolation in the language. Every program has bugs. Extremely stable programs don't expose their bugs during the useful life of the software. Erlang does it differently. It crashes. Erlang crashes all the time. Marvin Minsky, the guy who started the MIT Media Lab, he wrote a paper once called "Why Programming is a Good Medium for Expressing Poorly Understood and Sloppily Formatted Ideas." Why programming is a good medium for expressing poorly understood and sloppily formatted ideas. It's a lot harder to know what we're supposed to do as programmers than it is to tell computers how to do it. We can specify the parts we know pretty easily, but it's the vast universe of the unknown that bites us in the ass. I have a guideline I use for programming that I call Dirac's first rule. I'm pretty sure I heard it from Theo Dirac directly, but I haven't found anybody else attributing this to him, so maybe I have it wrong. Theo Dirac is the founder and leader of a couple highly secure open source software development projects, OpenBSD and OpenSSH. He taught me that the first rule for writing secure software is to make sure it does exactly what it's specified to do, and nothing that it's not specified to do. Security exploits rarely take advantage of properly functioning code. They take advantage, they exploit software that's doing something it's not supposed to do. In some ways, you could say that Erlang embodies this approach. Here's another quote from Joe Armstrong. Exceptions occur when the runtime system doesn't know what to do. Errors occur when the programmer doesn't know what to do. In Erlang, we can code to the specification and simply let anything outside of that specification be an exception that crashes the process. We don't have to defend against every exceptional conditioning. We can simply tell Erlang what's acceptable and let everything else crash. Let everything else crash. To be perfectly honest, I've had a hard time wrapping my head around Erlang. I've got the syntax, but I feel like I missed the gist. I've heard about that telephone switch at British Telecom that reportedly ran for 9 nines of uptime. It's really impressive, right? I've heard about the case study that says that Erlang code is 80% smaller than comparable C++ code. Sounds amazing, like I can do 5 times the amount of work in the same amount of time. I also knew that Erlang came from Ericsson in the telecom industry. With amazing pattern matching and a functional programming language, it seems like Erlang would be a great choice if I'm doing heavy network-oriented programming, like an API router, or proxy, or messaging. had trouble seeing how amazing uptime and code-based reduction fit into a bigger picture. And it's like this. A big part of the savings from that study, the C++ version versus Erlang one, 27% of the savings came from coding for the successful case and not needing to do the defensive coding. A big part of the uptime is that we let it crash. And when we don't get the successful case, we let the system crash, we let the process crash. And it's what we do after the crash that makes it fault tolerant, not just incredibly stable. And Erlang is good at network programming, but that's just a side effect of Erlang being good at a lot of things. So now I see the big picture around Erlang, the parts of Erlang that make it Erlang. At the lowest level, we've got Erlang's functional foundation with immutable data and program flow that's based on pattern matching. Pattern matching for the successful case. A layer up from that, we have Erlang's concurrency, with supervisors watching workers and cleaning up any messes they leave behind. And OTP providing boilerplate implementations of our most useful concurrent patterns. And then finally, there's Erlang's let it crash mentality, an acknowledgement that failures happen. And when they do, we can deal with them. The world is a stage, and we're all actors upon it. We talk, we grow, we fail, we heal. We're hopelessly separate, and yet we find ways to connect. We can't change the past, but we can take care of each other. And that's how we program in Erlang, too. Any questions? No, I meant to say, I'm sorry, I have questions for you, not the other way around. Who's programming in Erlang now? Wow. Hey, Randy, it's good to see you.
Hey, Rob, it's good to see you again.
Thanks for coming by. Yeah.
I know it's not directly in the scope of your talk, but just as a general rule, how do you get around the, for example, if you want to make a service that responds to requests, you can't be totally immutable.
You're not.
So, you don't have to go to the syntax, but what's the idea? How does Erlang handle that? How do you isolate those things that are immutable and pure functions with those things that have side effects and need to change?
Right. So I guess, like when you look at, and Randy might be able to correct me if I'm wrong on this, but even when you're looking at a database that's a functional data store, say like an event store, you're going to return a different value for the same request, right? And so on the one hand, you've got immutable data, but a side effect. You can change that, what you're going to get from a function. Or you can have mutable data. And I guess, like ETS and DETS, data stores in general, there are other ways that you can do it too in Erlang where you can make data mutable, but not easily, and not in a variable.
So the language, instead of like most languages, by default are procedurally done and mutable, Erlang provides the opposite defaults?
Yeah, Scala is like that too, where it ships you all of the immutable versions of the data structures for free, but if you want an immutable version, you have to load it. Erlang doesn't even do that. Variables are immutable. There are ways that you can store data that changes, even when the data is stored immutably, like in a functional data store, and get the current version of the data out. Randy, you...
Yeah, so think of it like this. Like if you look at Cowboy, which is a web framework that is on top of Erlang, like every web request is past state. And every time you service that request, you modify the state and return it. So that the state is always being passed back to a process which owns that state.
So a given state and a given request can go into a pure function and always return the same result. Is that?
It could return the same result, but it might return new state.
Right.
So what you do in like Cowboy is you basically hand the request back on the return along with the state that you mutated. Or maybe you don't mutate any state at all. Like maybe you say the user can't log in, return a 401, but the state doesn't actually change.
So in most functional programming languages, it's a common pattern. You've got pure functions, and you pass in one state, and you get out the next state, and that's a transformation.
Okay.
And that transformation is the fundamental pattern in
So one
functional
thing,
programming.
so one thing to look at, like for web stuff, like look at Web Machine. It basically pattern matches off of like headers and request path, and every single thing that happens is basically prescribed. Like if you don't pass the right stuff, it hands you back a specific error code. It's a really good way of building a REST service because you have a very prescribed way of building this. You just focus on the actual job that's being done, and not whether or not you should return a specific error code because the framework handles all of that for you.
Any other questions? Okay.
Where do I go next if I want to learn Erlang?
I like the book Learn You Some Erlang for Great Good. It's by Fred Herbert, H-E-R-B-E-R-T. He's on the routing team at Heroku.
Learn you some Erlang?
Learn You Some Erlang.
Yeah, Google search that and they have it all online too. It's free.
Yep. Yeah, the whole book's available online. You can also buy a copy of it. And Fred is great. He also wrote another book called Erlang in Anger, which is about debugging running Erlang systems. And I just love that too. Erlang in Anger. Doesn't it sound like kind of badass?
That's what you do when you code things that you want to get done. Yeah.
So who's doing functional programming otherwise?
Messing around.
Messing around.
Learning Clojure.
Okay. How do you like Clojure?
It's cool. It's fun.
Are you learning Clojure too?
Just for nothing.
Okay.
Trying to do like Haskell. Just kind of messing around also.
I'm sorry, I couldn't
Just
hear
trying to
you.
mess around with Haskell.
Oh, cool. And how do you like Haskell?
Yeah, I'm working on it.
I sat down with Will Bird from the university a couple of weeks ago. I'm like, yeah, everybody I know who's learned Haskell wasn't using it in production for 2 years. You know, you learn Haskell, and then you learn why you don't actually want to use it. And Will just stared at me, and it started to wither a little bit. And then he finally said, I don't find that to be true. Then he told me about a company in Portland, and what they do is write code that can be proven in every possible case. Okay, so their formal verification is complete. And if you're working on something that your life depends on, it's good to have that kind of stuff. Most of the work that this place does, and I don't remember the name of the firm, but most of the work that they do is for government applications. And most of the work that they do is written in Haskell because it's purely functional, except for the I/O, which is the only side effects you can do are I/O related, and you do that through a Moan app, which I'm not going to be able to explain.
Does Haskell have something like EQC for property-based testing?
Yes, and as a matter of fact, property-based testing started in the Haskell community. Quick check.
Right. So EQC is the Erlang version of QuickCheck.
Exactly.
Erlang QuickCheck.
Yep. So with Haskell, it's you can reason about every state for or at least it's mathematically possible to. The weird thing about Haskell, though, and I didn't know this until Will explained it to me, is everything is lazy. That nothing is, even though you might say this is equal to that, or this is equal to the result from this function, it doesn't store the result from that function. It just gives you a promise for it, really. I mean, it just says, okay, well, if you ever need this, then I'll go figure it out. And so it makes it kind of difficult to predict how long a complicated Haskell program is going to take at any given time. But you can determine all of the outcomes. So Clojure, Haskell, nobody's doing Scala?
I do some Scala.
How do you like
I did it. So I recently changed jobs, but I did Scala in the previous job, and I liked it a lot.
Cool.
Like the mixture of the object-oriented and the functional.
Did you-
Mostly with the functional and then mixing the objects.
Okay. And I've heard people say Scala is the gateway drug for functional programming. I've actually heard Scala is the gateway drug for Haskell.
I did it backwards. I went Haskell and Scala. So.
Yeah, I kind of approve. I kind of feel like if you get into Scala and then you're writing Java, basically, in Scala, that you haven't really gained much, but I can see where that can help move you towards more functional programming. You still have the classes, and then basically, like, the classes are implemented functionally.
Yeah, you can do. They have like like bind and map and filter or filter with and a bunch of other stuff to allow you to do functional stuff. But then you also use objects and inheritance and stuff to org structure your data and stuff. That's really interesting. Another language I like is Rust. So just gonna throw that out that does some functional stuff as well.
Well, yeah, that's a good question. So who's using like object-oriented and imperative languages, but doing functional programming in them?
I mean, like in JavaScript, you have a lot of, you have the option to write functional style.
Mm-hmm. And there's some really good functional libraries, like underscore and Modash, and promises.js.
There's a couple libraries for JavaScript for immutable data as well,
Oh, cool.
which can really help. Like I use it a little bit in my Angular applications to make the digest cycle quicker, because it just checks really quickly and then doesn't have to iterate through everything before it updates your DOM. So.
Yeah, nice. You had another question?
Yeah, and have you heard of Elixir, and what are your thoughts on that? Because
I love Elixir.
I was trying to decide whether, basically, I kind of want to jump into either Erlang or Elixir, and I haven't decided which one I want to dive head first into.
Well, a lot of people are working with both of them. When you learn Elixir, you really are, in a lot of ways, learning Erlang as well. There's only a few things in Elixir that Erlang doesn't do in a pretty similar way. I think, though, like one of the things that's attractive about Elixir for some people is the fact that it kind of looks like Ruby. I think that's a red herring. If you approach Elixir thinking like a Ruby programmer, you're going to get really confused. But it is a more comfortable syntax for, I think, programmers today. I started programming like 10 years before they started. Okay, so I started programming in '79. They started working on Erlang in '87. And I heard about it in the mid-'90s. I didn't bother to start learning it until 3 years ago. Started thinking about learning it 3 years ago. So to me, it's not that weird. But I programmed in Forth for 3 years as well, so that was pretty normal. Randy?
The thing with Elixir to watch out for is there's a lot of meta programming that it allows, and that makes it kind of dirty.
Yeah.
But it solves some problems with Erlang. Like in Erlang, the character strings are kind of messy. It's better to just use binary types for that. And like, you have the option Erlang, but Elixir forces everything to binaries, which is like more efficient for the DM. But there's meta programming, so there's some dragons down that path. The plug is pretty decent. It's like Rack for Ruby. And then the Phoenix framework is pretty good too. It's coming along nicely. Some of the stuff in the Phoenix framework I wouldn't use, like channels is garbage. But it's coming along. So there's some good things there. I think Erlang overall, it's used in places people don't expect. Like Rob mentioned, WhatsApp is one of them. But like if any of you have played League of Legends, it's used for the chat system there. It's used at Comcast to control like your session profile for like what channels you have. Best Buy uses it for the product stuff on their site. It's all over the place. It's just nobody really knows.
One of my favorite things is if you go to, I think it's Erlang.org, but it might be an Erlang Solutions. There's a graphic with a bunch of logos from different companies that are using Erlang. And if you look towards the bottom right-hand side, one of the logos is for Battlestar Galactica.
What?
Battlestar Galactica is in that list. And it turns out the Battlestar Galactica actually does run Erlang, but the Battlestar Galactica they're talking about is the company that makes the game, Battlestar Galactica. But then you're thinking, okay, well that's really cool. But what, do the Cylons run Erlang? I don't know.
I know the Visa's hiring right now, a lot of Erlang developers too.
Who is?
Visa,
Okay.
and
Oh,
also
nice.
OC Tanner.
I don't have any openings right now. I just filled my last current opening, which is a shame because I gave a talk this morning on how to get hired as a software engineer. Okay, oh, yes.
In terms of like web server development, I know there's a Yaz web server. Would you recommend using that, or does Apache have like a plugin?
I would go with Cowboy.
Yeah, I like Cowboy too.
Like Cowboy, Web Machine, or Yaz, depending on what you're after.
So Cowboy's a web server?
Yeah, it provides a nice interface for like REST services as well as WebSockets.
Okay.
Cowboy is great, and it's written by the guy who wrote the Erlang.inc file as well, and a number of other things that fit into the Cowboy ecosystem. So Luke is, I think Luke is a really good developer in the Erlang community to follow. And if you're looking for something and you see that he's made something that fits like in the right area, it's a good place to start. Yeah.
Another question, pretty basic. Does Erlang run on a virtual machine, or is it compiled to binary?
Yes. Yes. Just don't run on Azure.
Oh, really?
Yeah,
I haven't
we're
tried
having-
running on Azure.
We're having.
Wait, so when you say yes, which one did you mean?
Yes. Both.
You
It
can
runs
do
on
it either way?
You can compile it natively, or you can run it on the virtual machine.
Okay, so there is a Erlang interpreter, or I'm confused.
Okay, so when you
So what I mean,
compile,
like
it compiles-
Java compiles to a bytecode and then runs
Yes.
on the JVM.
Exactly, just
So-
like that.
So Erlang runs like that, but you can
Yes.
also compile it
Our
to bytecode.
virtual machine is called Beam,
Uh-huh.
and it compiles down to a bytecode that runs on Beam.
Uh-huh.
And you can pass in a switch when you're doing the compiling to get a native compilation.
Okay.
So that's accurate, right?
Do you have to compile? Is there like Python glide or something like that?
Yeah, there's a high performance Erlang will compile to native code.
So if you're asking though, like RubyPy or like Python?
No, I'm just saying like messing around like on the command line. Like, typing
So you've got Erl shell.
Erl
and
shell.
you can do a lot of stuff in there. But where I was talking about the code not running, the way that I show it in my presentation,
Sure.
that's because of the statements versus expressions. Okay? So in Erl shell, if you want to play with functions, you literally have to say, okay, well, this variable I'm going to bind to a function that does this, just like you would in JavaScript, or very much like you would in JavaScript, or can in JavaScript.
You can attach to a running process too. So like like with Ruby,
Oh, okay.
you can't really attach to a running Ruby process, right? But you can in Erlang. You could.
And then to get information out of another process, you'd have to like ask it for a message or something?
Yeah, and like you can also do that across nodes. So you could do things like turn off all the web machine endpoints for this route on all nodes.
So you could like basically log into the process and say shut everything off or restart
Yeah.
everything?
Yeah,
You can, yeah.
and because all the nodes are connected through dist Erl, like
Yeah.
you can say turn off all these things for yourself and all connected nodes.
Interesting.
So, but in terms of like getting started with Erlang and
Yeah.
playing with it, you can launch the Erl shell, and once you've installed Erlang, it's just ERL, okay? And then you can start interacting with Erlang, but it's all expressions at that point. Everything returns something. So you can't start defining the functions in there unless you do the kind of hacky workaround. That's one of the things that Elixir fixes in Erlang, is that the Elixir shell lets you do full-on statements and expressions. Joe Armstrong calls that a bug in Erlang, and a bug that's been there for 20 years, that you can't do functions in the shell. And he actually, just as a proof of concept, made an Erlang version 2 once, or Erl 2, that, among other things, fixes that problem. But it's not something that's been accepted into the language, into the shell. So you can start with Erlang.make, and like I was just talking about, the guy who wrote Cowboy wrote Erlang.make, which is a make file for your Erlang project. One of the options that you have with Erlang.make is to set up a make shell. And if you run make shell then, what it'll do, depending on how you configure it, there's a little bit of configuration you need to do, It'll take the code that's in the directories, in the directory and beneath it that you're in, and automatically reload code when you change anything, and run any tests that you have. So you can use that for red herring refactoring and for test-driven development. You can also use that then to experiment.
Yeah.
It'll reload, it will crash. If there's any problem, you'll see the error, you'll see the line.
So do you like packages, how do you do packages, just directories? Is there like a magic file in there, like Python, and just goes for index? Something like that?
Yeah, but it's not that complicated. It's, everything is in well, everything's in the source directory. And I guess if you can explicitly compile and load, or if it's already compiled and it's in the build directory, then you just call it. You don't even have to include it unless it's outside of your
So you have
include
to
path.
import? You have to import?
Only if it's outside of your
Scope.
path, yeah. And when you run, you can specify
set
your
up-
path as well,
okay.
and you can change your path.
So you just can set your path right there on like environment variables. And there's like a default path I take it rather than that.
Yeah, just the local.
Yeah.
Yeah, the thing you probably want to go look at too is the application spec for OTP. It tells you how to like stitch applications together and build like an OTP release.
Cool.
Yeah, for an OTP release, there's a little bit more structure to it because you've
Yeah.
got, well, basically, it's just going to start up the supervisor and then do whatever you tell the supervisor to do. So typically, your supervisor is going to start one or more workers.
So we use FreeSwitch, so we do use one. But, and then everybody uses this, but, so you would start up like an OTP server if you were to use this for FreeSwitch, like to be able to handle like the call, and then I don't know, have you guys ever used that with like?
I haven't used-
Asterisk or-
Yeah, I haven't used FreeSwitch.
Oh, okay.
Is that Python?
No, that's all C, it's all compiled.
Okay.
It's just a telephony server, and then they use,
Is it based on Asterisk?
yeah, it's basically the 5 years more advanced version, you know everything down with it.
And it's been longer than that since the last time I used Asterisk.
So there you go.
Okay, we're out of time. Any last question? Thank you.